So, dear success and hardware lab, experiment number 10. In this lab, you are actually asked to implement a binary search tree with insert, uh, in order, pre order, post order, and level order. That is, I was BFS. So, I've just made my own program here. I'll just show you the output first, then I'll go on with the explanation. For the example, I'll just make this tree, binary search tree. Answer of first insert 50, 40, 20, 40, 70, 60. Okay, so I inserted it. Before that, just I'll do it once more. Just look out for the code. Yeah, use for the okay. And this is it's computer or it's that was not a more suggestion. Okay, so insert in 50, 30, 20, 40, 70, 60, 80. Okay, first thing would be in order. So just printed 20. Just copy this and I'll explain it to you. I printed. I'm so sorry. So first output was 20, 30, 40, 50, 60, and 70, 80. Okay, in order thing. First you start from the left root node, then right, then left again. This is the root node, and then again go here. Left, right, root node, left root node, right. So this is in order. What about pre-order? Pre-order. So it's like root node, left, left, then right, right. Okay, it's like all left, then right, then uh, root node, left, and right. This is pre-order. Then you go for post order. Uh, this is post order. So it's like 30, 40, like all this elements in the bottom, then these elements this way, then finally everything. This is post order. Then last one, level order BFS. This is basically what you see like this. Root node, left, right. Then root node, left, right. Like as 30 is already printed, we just have to put left and right. Then as 70 is already printed, we just print 60 and right. So root node, left, right, left, right, left, this is BFS level order. So that's all for the output part. Now I'll go on with the code. So I'll first say name. This is for the identification that this code belongs to me. That's it. Yeah, this part. And I have a choice variable and a data variable. I initialize the root that is null. Then I just printed the menu. Okay. Then I got the choice from the user. Uh, until this is 6 means exit. This while loop will be running. The control will remain in the while loop. Inside this while loop, I have a switch case statement. So based on the choice, we have like functions being called inside. If the user enters anything other than 1, 2, 3, 4, 5, 6, the call statement is being executed. Then again we print the choice. After again we print the menu, get the choice, and it will run. So first one was insert. Enter the data to be insert. We ask the user for the data to be insert, store the data, and give root is equal to insert of call the insert function with two arguments, the root node and data. So first for the node, I used a class. I have a data variable and two pointers left and right. I have a I have a I have a constructor here which has one argument data. So this constructor will initialize the data available to this data and will initialize left and right pointer to null. So first one is insert function as we saw. That's two arguments. The for root node and for data. So this is actually a recursive statement. Base case is if root is double equal to null, then make a root. If the root node is null, then make a new node and then return that new node. Recursive cases, if the data to be inserted is less than the data in the root node. Okay, so in that case, like in that case what we do is we are going to insert it to the left side as it is a BST. We are going to insert it to the left side. So I made root of left is equal to I'm calling insert function. This insert function using recursion will pass me the pointer to the left side of the tree. Say in the left side there is already uh, like say for example for inserting 20 already we have 30 and all in the left side right. So so what will happen is first we go to 50 and then we check if the node to be inserted data to be inserted 20 if it's less than 50. In that case it says root of left is equal to it calls insert function on the left side now. So now root becomes 30. Again it checks. Is 20 less than 30? Yes. So for 30 again it calls the same thing. Root of left is equal to insert. Now root of left will be null. So as root is double equal to null, we insert and return the root point. So insert 20 here and return the pointer to 20. This will in turn be stored in the root of left of 30, which will in turn be stored in the root of left of 50. And finally, we return root, that is 50. Okay. Similarly, the else if case, if the data is greater than root of data, then root of right. So this is a recursive case. And I've had this statement for my understanding. We don't have a case uh, like some people might have this doubt, like what if the data to be inserted is equal to the root node? A point to note in a BST, we don't have duplicate elements. So this is for my reference. I added it up. Okay, so for duplicate, we won't have any BST. Okay, then that was insert function. Now in order, I just have one argument root. Okay, yeah, I'll explain here. This is also a recursive function. So like for in order, you see here, first go to the end, print the left node, root node, right node, right? That was in order. So for that, uh, this will make sure that the that it goes till the end 20. Then I print the root node there. I can't explain it to you. Like in recursion, we just assume that recursion just prints it. So okay, instead of explaining it like that, I'll explain to you this way. So for in order, first print left, then print root, then print right. Right. So assume recursion will print the left part of the tree. Imagine there's only 50, 30, and 70. Assume will print the left part of the tree, then print the root node. Then assume recursion will print the right part of the tree. So I'm using the statement. So I'm assuming recursion will print the left part of the tree. Then I'm printing the root node, and I'm assuming the recursion will print the right part of the tree. Base cases, we'll only do it when root is not equal to none. So I just added the base case along with this indicated with this. This was in order. So for pre-order also same thing. Uh, uh, for this also we only have one argument. For this also we only have one argument. We only have only one argument. For pre-order, if you notice, it was root node, then like root node, left side, left part, then right part. Then root node, left part, then right part. So it was like first left part, right part. So you see here, pre-order. First we first we put the root node, assume recursion prints the left part, and then we print the right part. So this was pre-order. Post order would be uh, okay. Post order would be like this entire row, this entire row, this entire row. So for that, what we will do is assume recursion is the left part. Assume recursion will print the left part. Assume recursion will print the right part, and then we print the root. So see here, assume recursion. Okay, imagine it's on 50, 30, and 70. Assume recursion will print the left and the right. Right. So a call to the left and the right. So this entire row is done. Then we print the root part. So that was post order, then level order, BFS. Here it's like root left right, root left right. So root left right. So first print the root one. Assume recursion prints the left part. Okay, here this will have exactly the same. Okay, for this I used Q. So base case would be if root is double equal to null, then nothing. I'm having Q here. I'm just passing the root node to the queue. Then, uh, then after that, then after that, I'm I'm just printing the root node, then popping it up. Okay. Then I check if left side of the if there's an element in the left side, if there's a node in the left side. If that's the case, then uh, push that and print it. If an element is in the right side, if that's the case, then then we just push that and print it. So that's what the statement is. So it will actually be DFS level order. So 50, 30, 70, and 20, 40, 60, 80. Uh, that's all, I guess. Yeah, that's all I guess. So that's all, and thank you.